8.3, we're graphing reciprocal functions. Reciprocal functions basically means 1 over. And so in that problem number 1, when you see 1 over x, that's what we're talking about. In this case, it's 1 over x minus 2, and they're all going to kind of look the same. All right. So we want to graph 1 over x minus 2 plus 1. And there's going to be something weird that you have to deal with, and you do have to deal with this. It's called asymptotes. Asymptotes are like invisible boundary lines. You're not going to see them when you graph it, but it's definitely a boundary. All right. So here's what I want you to do. I want you to circle this denominator of the fraction, x minus 2. All right. We want to know what x number makes this equal to 0. All right. Because that number is going to be bad news. So tell me, what number is going to make that equal 0? Right, positive 2. Okay. If you get x equal 2, x equals 2 is going to be bad news. All right. That's going to be one of your asymptotes. All right. So what we can do is draw a dotted line vertical like this through x equals 2. That is a vertical asymptote, VA, vertical asymptote, x equal 2. All right, so go ahead and do that. Then the other thing we want to do is let's underline this other number over here, plus 1. Okay, plus 1. What that's going to do is it's going to shift the graph up 1, and that's going to be a y equals asymptote. Y equals that number. I don't have to do the opposite or anything like that. I just do whatever that number is. Y equals 1. Y equals 1 is going to look like this. It's a horizontal line. So it's a horizontal asymptote, HA, horizontal asymptote, y equals 1. Those are the boundary lines for our graph, and they're going to be important parts of the graph. So go to Desmos and type that in. Y equals 1 over x minus 2 plus 1. And you're going to get this weird looking shape. I call it a double boomerang. Kind of looks like 2 boomerangs. But that's what we're going to draw. But if you notice, like imagine if you drew a plus sign in between those 2 boomerangs. These 2 blue lines that I just drew are in between those 2 things. Those are boundary lines, okay? So what we really need to do is figure out some points. And if we didn't have Desmos, we'd have to do this completely by hand. So we would say, okay, if I make an XY table and I can plug in some numbers, I know I can't plug in 2 because 2 would give me a 0 on the bottom of a fraction, which is no good. But I can plug in pretty much anything else. So what if we plug in 0? If we plug in 0, we would have 1 over 0 minus 2 plus 1. That's 1 over negative 2 plus 1. That's negative 1/2 plus 1. That's 1/2. And so I have one of the points on my graph, 0, 1/2. 0, 1/2 is right there. 0, 1/2. All right. But if you're looking at this on Desmos, you might just be able to click right there. There it is right there, 0, 0.5. 0, 1/2. I didn't really need to do that math there. All right. And here's another point. 1, 0 is another point. So graph the point 1, 0. Usually, if you can get a couple of 2, 3 points, whatever, you've got a pretty good idea of what this looks like. So I'd say 2 points here is enough for me. I'm going to make it flat to this line. Don't cross it. It's your boundary. It's like an electric fence. If you touch it, you'll get electrocuted. And then we're going to go down and kind of get vertical to this line. Those dotted lines, those asymptotes, form the boundary of my graph. All right, so that's half of my graph, you can tell but from Desmos. So there's a couple of different ways of finding the other side, the other boomerang. You know, one thing you could do is plug in another number. So, you know, let's say we plugged in something over here like 3. If we plugged in 3, we'd have 1 over 3 minus 2 plus 1. Okay, so that's 1 over 1 plus 1. That's 1 plus 1, that's 2. So we'd have the point 3 comma 2. 3 comma 2 is right there. All right. But what you might notice is there's symmetry. If you start at like this point right here, see this point? If you go over 1 and up 1 to the middle, you can go up 1 and over 1, and it's right there. All right. So it's pretty much symmetrical. So you look at this point right here. If I go over 2 and up a half, means I should go up a half and over 2, and there should be a point right there. You can just kind of use symmetry to find the reversed point. Use your boundaries to draw your curves. Do not cross the boundaries. Use those as guidelines, but that's how your curve's going to look. All right. So that's pretty much it. We're doing that, and all of the graphs today, anyway, I think are going to look pretty much the same. So if we look at number 3, okay, first thing, find those asymptotes. Don't skip this step. I know Desmos doesn't make you do that step, but I want to do that step first. So first step, for your horizontal asymptote, just tell me what's going to make 0. Come on now, what's going to make 0? -1. -1 plus 1 is 0. That's bad news. All right, we can't have 0 on the bottom of a fraction, so -1 is always going to be a bad deal. So that is, oops, I said horizontal. That's not horizontal, that's vertical. I'm sorry. That's your vertical asymptote. So here, x equals -1. X equals -1. This one is going to be your vertical asymptote. Vertical asymptote, y equals 1. Whatever that number is, that's your, oh my gosh. I'm a mess today, huh? That's your horizontal asymptote. Thank you. Y equals 1, horizontal. So your graph's going to be a double boomerang with those as the boundaries. So check it out. If we graph that, type it in, 3 over x plus 1 plus 1, doesn't it kind of look the same? Pretty much the same deal. All right, you with me? So let's find some points. Click around until you can find a couple of points. There's 0, 4 and -4, 0. All right, 0, 4 is right there. -4, 0 is right there. You feel like that's enough to draw your graph? Maybe. You want to do some more, do some more. You can always plug in something. Like, let's say we plug in, I don't know, let's do 0. That might, oh no, we already did 0, didn't we? If you plug in 0, that's going to be 3 over 1 plus 1, that's 4. We already have that point. So let's do 2. 2 would be a good one. 3 over 2 plus 1 plus 1. That's 3 over 3 plus 1. That's 1 plus 1. That's 2. 2, 2. Got the point 2, 2. 2, 2. Right there. But we can use symmetry. All right? We can use symmetry. Think about how far that is from the middle. See how you'd go over 3 and down 1 to get to the middle? The middle. Not the origin, the middle of my lines. The middle of my asymptotes. If you go over 3 and down 1 to get to here, then you go over 3 and you go down 1 and over 3. Well, that's this point right here. Okay. So let's use symmetry on this point. That one's down 3 and over 1, so let's go down 3 and over 1. We're right there. Symmetry. Use your lines as boundaries. Look like this, double boomerang. You know, or another thing you might be able to do is if you just like click around, you might be able to find some points. You know, click and drag, find a point, something like that. Okay. All right, let's move on. Next one, number 5. All right, so starting with this thing, this is the, which is it, horizontal or vertical? I screwed it up last time. That's a vertical asymptote. X equals what? X equals -2, very good. So your vertical asymptote at x equals -2. Draw that first. Now this one's weird because it doesn't have that extra number at the end, but if it doesn't have that extra number at the end, then what is it? Yeah, we could think of this as +0 if we want. +0 if we want. And so that way we know our horizontal asymptote is y equals 0. Y equals 0. So those are the boundary lines for my double boomerang shape, my reciprocal function. They're all going to pretty much look the same. So right there, is that pretty much the same exact picture? Let's find some points. Here's a point at 0, 1. At 0, 1. 0, 1 right there. So can anybody use symmetry to find a different point? Very good. Right there, right? Left 2 and down 1. So if you go left 1, I mean down 1, left 2, it's right there. Symmetry. That might be enough. That might be enough to draw our graph. This. Could we find more? Well, sure. We could find more if we want to. I don't know that we need to today. All right. Getting good at this, getting comfortable with this. Question? Well, because there was nothing there, right? And so if there's nothing there, it's not like it's nothing. We could always say +0 if we want to. So all of the other ones had a number at the end, +1, +2, -1, whatever. You know, this number right here is what tells me that horizontal asymptote. And if there's nothing there, it's the same thing as saying +0. I did 1, 3, and 5. All right, now. Oh, I see. Yeah. Okay, number 7. There's one thing that's different about this one. You see that negative? All right, that means it's going to flip. Very good. It's going to be the same shape, but it's going to be flipped. All right, so I'm on number 7, and we're going to do the exact same thing, though. So don't worry about that yet. All right. What's my vertical asymptote going to be? Right, x equals 3. So we're going to have a vertical asymptote at x equals 3. And my horizontal asymptote, y equals -1. Yeah, I think everything I've written right here you should write down. Yes. Believe me, I'm giving you shortcuts by not making you make a table and do a whole bunch of points. Like in the olden days, Desmos wasn't a thing. Graphing calculators weren't a thing. We had to do everything by hand, and you're making XY tables until you get enough points. That's tedious. This isn't that bad. All right. So if I'm looking at this graph, don't forget your negative. Okay. That negative is going to flip it, okay? It's going to flip it upside down, and we need to find some points. So usually the easiest ones to find are like the intersection points. I see the point 2, 0. I see the point 2, 0. So if you've got the point 2, 0 right there, can you give me a point that's symmetric? 4, -2, very good. Over 1 and down 1 puts me right there. All right. And typically that's going to be enough for you to know what the picture looks like. All right. We're not trying to be super duper accurate with this. I can do another point that looks like 0, -2/3. 0, -2/3 is about right there. And so if you go over 3 and down 1/3, down 1/3 and over 3, looks like there'd be a point right there, just based off symmetry alone. So flat to this asymptote, hit the curve, up, vertical to this one. Flat to vertical. Don't cross those boundary lines. Those are like electric fences. You touch it, you're going to get zapped. All right. So draw your double boomerang, and notice the difference between number 7 and number 5 or whatever. Number 2, number 1. I meant number 3, of course. That's 1, 3, 5, and 7. All right. I'd say that's good enough. So your job, you're going to do the evens on that worksheet. Let's go.